It will soon be 50 years since vitrectomy was invented. Vitrectomy was invented in 1974 and was an absolutely archaic surgery in which a small hole was performed then of caliber 17G within. Inside the sclera of the white part of the eye, you would go in and try to grind up the vitreous and suction it out. It wasn't until the next decade that performance vitrectomes came out on the market and vitrectomy surgeries began to be performed. Thus, vitrectomy began in the 1980s with the diameter of 20G. The G, also called gauge, is the diameter of needles internationally established. 20 corresponds to an outer diameter of 0.9 millimeters. Vitrectomy has evolved over the past 40 years. From the 20G, it has gone to the 23, the 25, and finally to the 27 for 7 to 8 years now. The 20G vitrectomy is a vitrectomy that is still performed today, especially in complicated cases. Of course, the holes in the white part of the eye that are performed are of a fair size and therefore need to be sutured at the end of the procedure. With the advent of the 23G, the 25, and the 27G, there has been a move toward miniaturization of the ports, and thus an improvement in the performance of the surgeries, and thus an improvement in the compliance of the patient, who has a much faster visual recovery and a much less uncomfortable post-operative. The surgery is performed under local anesthesia and targets all diseases of the retina and vitreous. The diameter of the ports with which the surgery is performed, which are basically 3 or 4 or 2 depending on the type of treatment that is done, are of a diameter that has been decreasing over the years. So we have the state of the art today, which is the 27. The 27 corresponds to 0.41 millimeters, so we went from vitrectomy 20.9 to vitrectomy 23G 0.6, vitrectomy 25 0.5, and finally vitrectomy 27 0.41. So as the number of G's, of gauges, the diameter decreases if we go to calculate the area that goes to affect the performance of the instrument that we go to insert. We realize that there is a much bigger difference, because if we think that a 25 vitrectomy is equal to a 23 vitrectomy is equal to a vitrectomy 27, we make a big mistake. From vitrectomy 20, so with a diameter of 0.9, we went, starting from an area of 0.63 millimeters, we went to an area with the 23G of about 0.28 square millimeters, and so we have a halving of this diameter. The performance from 20 to 23 was been much higher, so we basically have the diameter. On going from 23 to 25, we went from 0.28 to 0.19, so we had a further miniaturization, so 0.19 square millimeters. Recall that we started from 0.63 with the 20G. In the end, today's state of the art, which is the 27G minimally invasive vitrectomy with a diameter of 0.41 millimeters, insists on an area of only 0.13 square millimeters, which is nothing more than almost half the area of 25G. So going from 25G to 27G does not mean decreasing the diameter by only 0.1 millimeter, because actually the area we are going to work on is almost half. So the performance jump between 25G and 27G is not only 0 at 1 millimeters, because you don't have to calculate it in a linear sense of diameter, but you have to calculate the area. The area went from 0.19 to 0.13 square millimeters, so it is almost halved. In fact, while the performance of the machines remains the same, and therefore operation times are practically the same as the 25G, clearly the miniaturization has allowed us to work much more on the small, and therefore to be absolutely preferred a 27G vitrectomy for issues purely of diameter and size of the objects we are going to insert into the eye.